Good morning. This is Unit 3, Day 5 notes. We're going to go over classifying whether these lines are parallel, coincident, intersecting, or skew lines. Remember parallel lines? They have to be on the same plane, but they never intersect. They have the same slope. The angle between these lines is going to be 0. If this is A and this is B, or vector B, then vector A is equal to a scalar times vector B. For some K, that's a scalar. Oh, a number. Okay. Remember that there can be no shared points. If there are shared points and they have the same direction, then they're coincident. A coincident vector, or vectors, are going to be vectors that are also parallel, but they're on top of each other. They're the same line. So maybe this is going to be a vector, and also the one on top of it is going to be a vector. So they are the same line, so there's going to be infinitely many solutions, and vector A is still equal to vector B for some scalar K. Scalar. Okay, intersecting lines, whether they're perpendicular or they just intersect, the point of intersection is right here, and this angle in between them is theta. You can also find this angle in between it by using our formula. This is the point of intersection, so it's where they intersect. The angle between is theta and has a point of intersection, so they have one common solution. And that is that point of intersection. Skew lines. So we learned this in geometry. I don't know if you guys have seen this since, but skew lines are non-coplanar. They're not on the same plane. And they never intersect. Never intersecting. Alrighty. So they have no point of intersection. They're not going to have a common solution. And we can still calculate the angle between when one line is translated on top of one another. If we can bring this one down, then we can find the angle in between them. So we're going to translate it. That's when we shift it up and down. We don't rotate it, we just shift it. Okay, for non-zero vectors u and v, so it's just not 0, 0, the perpendicular test, remember, if theta is equal to 90 degrees, then u dot v, this is a u dot v, the dot product, is equal to the magnitude of u and the magnitude of v, cosine of theta. That's our formula. Usually we solve for cosine of theta. Therefore, my dot product has to equal 0 for it to be perpendicular or meeting at a 90-degree angle. Now, parallel, we want it to equal either 0 degrees, theta equals 0 degrees, or 180. I'll show you. So these are a little bit different. Number one, when u is equal to k times v, where k is a scalar. Write that somewhere. K is a scalar. If theta equals 0 degrees or 180 degrees. U dot V, the dot product, is equal to the magnitude of U, magnitude of V, cosine of theta, or 2, if U dot V, the dot product, is equal to plus or minus, we know that cosine at 0 is 1, cosine at 180 is negative 1, so that's why we have a plus and minus. U, the magnitude of U, magnitude of V. Then U is parallel to V. So if our theta, if our angle is 0 or 180, then we have parallel lines. If our dot product is equal to 0, then we know that we have perpendicular lines. All right, it says find t if negative 4t 1 minus t is perpendicular to this vector. So remember, if it's perpendicular, then our dot product has to equal 0. Okay, they're telling us then that our dot product is equal to 0. So I'm just going to do the dot product of negative 4t 1 minus t. The dot product, dot t, negative 6 minus t. All right, the dot product is when we multiply the x's and then add it to multiplying the y's, add it to multiplying the z's. So we have negative 4 times t is negative 4t plus t times t is t squared plus, this one, we're going to have to multiply them. So we have parentheses 1 minus t, and then negative 6 minus t. Remember, we're going to have to, and this equals 0. And we're going to have to FOIL this. So I'm going to bring down the negative 4t plus t squared plus negative 6, so minus 6. And then my outside two terms are negative t and positive 6t. So it's going to be positive 5t because we have the negative t. And then my last are negative t is plus t squared. Oops, there's a plus right here. Alrighty, equals 0. The t's and my pluses look very similar. So I'm just going to combine my like terms. I have t squared and t squared is 2t squared. And then I have 5t and negative 4t is just t plus t. And I have minus 6. I don't see any other numbers, so just minus 6 equals 0. This has to equal 0. So this is the quadratic. You can solve this by factoring, or you can use the quadratic formula, but you cannot solve by moving that 6 over, right? We have to factor it. So I know that 2t squared is 2t and t. I know the factors of 6 are 3 and 2 and 1 and 6. Let's just try 3 and 2. And then I know one of them has to be negative, one of them has to be positive because they multiply to be negative and they add to be positive. So the bigger one has to be positive. So 2 times 2 is 4. That one has to be positive and negative. And then I'm just going to FOIL it in my head to make sure that it works. So it says 4 minus 3 is positive t, negative 3. Perfect, negative 6 on our first try. So then we have 2t minus 3 equals 0. And then we have t plus 2 equals 0. Set each one equal to 0. And I know that when I solve for t, I'm going to add the 3 over, so it's going to be positive. So that's going to be 3 over 2. And I'm going to subtract the 2, so t equals 2. T could be either or. Okay, I'm just going to circle that. That's it. Solve for t. There you go. The next one says find m and n if these two vectors are parallel vectors. We know that if they're parallel, then my theta, when we use our formula, my theta has to equal 0 or 180 degrees, either one. So I'm going to write them as a vector. I know that this is negative 12, negative 20, and 2 equals, this has to be k times 3, and then m and n. Alrighty. So I'm just going to set up like an equation. Negative 12 equals 3k, 3 times k. If I divide by 3, k is going to be equal to negative 4. Okay, same thing for the rest. Well, then I know that this is negative 12, negative 20, and 2 equals negative 4 times 3, m, and n. Now I can solve for m. So I know the top one I don't have to solve for, but 5, or let's do this. Negative 20 equals 4 times m. So if I divide by 4, I'm sorry, this is negative 4. Sorry. If I divide by negative 4, m equals 5. I'm going to do the same thing for n. 2 equals negative 4 times n. If I divide by negative 4, I get n equals negative 1/2. Right? Try it, make sure I'm right. Alrighty, let's keep going. Alrighty, we're going to classify these lines. I'm going to make them into a vector first. So line 1. Just notice that they have different parameters. They're not both in forms of t. So line 1, they're both in 3 dimensions. Remember, it's our initial point, which is negative 1, 1, 1. Plus t times our direction, which is 2, negative 2, and 4. Let's do the same for line 2. It's still going to be x, y, z, 3 dimensions, equals 1. Ooh, this one doesn't have an initial point, so it's 0, and then 3. 1, 0, 3. Plus s this time times the direction, which looks like it is negative 1, 1, and negative 2. So negative 1, 1, negative 2. That's my direction. I see something interesting with this. These are my directions. I see that 2, negative 2, and 4 is a number times negative 1, 1, and negative 2. All I have to do is multiply this by a negative 2 to get this one. And they both change signs and they become this vector. That means that line 1 and 2 are either parallel or they're the same line. And that new word that we learned for the same line is coincident or coincident. Okay. So let's look at the points. Line 1 contains this point right here, 1, 1, 1. So I'm going to say line, let me just use a different color. Line 1 contains -1, 1, 1. In line 2, line 2, y is equal to s. So let's say s is 1, because we want to know if this is a possible solution. Then y can equal 1, but are x and z going to equal 1? Well, if s is 1, then I have 1 plus -1 is 0. Then it would be 0, 1, and 3 plus, when x is 1, this is going to be -2. So we have 1. This is not the same solution or the same point as this. So these are not coincident. They're not exactly the same line. So therefore, they're parallel. Therefore, they're parallel. Because these are not the same. Not the same. Thankfully. Okay. Let's do another one. Show that line 1 and 2 intersect and find their point of intersection and the angle between them. This is a very good question. Let's go over it. If they intersect, they must have a common solution. And I'm going to look at the directional vectors. So line 1's directional vector is -1, 1, and -2. Line 2's directional vector is 2, -1, and 3. 2, -1, and 3. They are not multiples of one another. If I multiply -1 times -2 to get 2, 1 times -2 will not give me -1. So they're not multiples of one another. So they are not going to be parallel or coincident. All right, if they have a common solution, then we can set them equal. We have our x's are equal. So 1 minus t is equal to 1 plus 2u. Also with the y's, my y's are going to be equal at some point, where t is equal to -1 minus u. And my z's are going to be equal at some point, so 3 minus 2t is going to be equal to 4 plus 3u. Now, what I'm going to do to find an equation is, this one is already solved for t, so I'm going to use this, and I'm going to plug it in for this t. So we have 1 minus t is -1 minus u equals 1 plus 2u. And I see this is 1 plus 1. I'm going to distribute this negative. So this is plus 1 and plus u. So we have 2 plus u equals, and then this is 1 plus 2u. I can subtract the u to move it to this side, subtract the 1 to move it to this side, solve for u. U has to equal 1. Now I'm going to plug this into this equation. So t equals -1 minus, well, u is 1. So t equals -2. And we're going to combine these and see if it works in our third equation. So this one, we have a point 3 minus 2 times t, which is -2. Does this equal to the right hand side, which is 4 plus 3 times u, which is 1? We cannot shift anything over. We're just trying to find out if they're equal. So this is 4, 3 plus 4. Is this equal to 3 plus 4 or 7? 7 does equal 7. Okay, so then they have a common solution. Therefore, they have a common solution. And that means that they intersect. We don't know how they intersect, if they're perpendicular or not. We need to find the angle in between them to find out if they are perpendicular. So we're going to substitute to find the coordinate of their intersection point. Well, u is 1. So I can find out where they intersect. When u is 1, I know that this is 1 plus 2. So my x is 3. When u equals 1, then I have 3, negative 1 minus 1 is negative 2, and then 4 plus 3, that's a 4, so 7. That's it. Solve for the angle between them. Well, we have a formula, but we need our directional vectors. So we're gonna make sure that we use the directional vectors. And we're gonna use our formula. So I know my directional vector for A is, I think I wrote it on top, negative 1, 1, negative 2, and B is 2, negative 1, 3. Right? We found them before. I'm just going to write them down so I remember. So negative 1, 1, and negative 2, I think. And B equals 2, negative 1, and 3. Tell me if I'm wrong. All right, so now we have a formula for this. We say cosine of theta equals A dot B over the dot product over the magnitude of A and the magnitude of B that's it. Yeah, cosine of theta equals this. All right, so this is not too hard now to find the dot product. The dot product is negative 1 times 2, which is negative 2, plus negative 1 times negative 1, which is negative 1, plus negative 2 times 3, which is negative 6, all over the magnitude of A, which is, I don't know, the square root of negative 1 squared, which is 1, plus 1 squared, which is 1, plus negative 2 squared, which is 4, so that's the square root of 6, times, and then the magnitude of B, which is the square root of 2 squared, which is 4, plus 1 squared, which is 1, plus 3 squared, which is 9. So 9, 14, square root of 14. So the cosine of theta equals let's just simplify this a little bit. Negative 9 over the square root of 84. Oops, 84. I don't know why I put 6. I don't know. You guys are going to have to plug this into the calculator. Remember, you're doing the cosine inverse of this. So in the calculator, you guys are going to say cosine to the negative 1. So second cosine of negative 9 over, make sure you put that negative 9 over the square root of 84. And then if we plug this into the calculator, we get approximately 169 degrees or 11 degrees. Alright guys, so that's about it. I want you guys to try the other two problems and I'll tell you what the answer is when we get into class. Alrighty? Have a wonderful day, guys.